So at first glance, it doesn't look like number 7 is all that different from number 6 before it. Note that I still have a function f. My f has changed from the last couple examples. And I still have a function g, which has also changed. All I'm doing with these functions is adding them together, but oh, this is different. Now I have an actual value that I'm substituting into those functions. So keep in mind, f plus g is really saying f of x, and we are adding that function to g of x. So we can evaluate both of these functions at -2. Again, -2 coming from our given here. We can evaluate both of our functions at -2, and then afterwards, just add them together. That's what this notation is telling us to do, to add these two functions together. So let's go ahead and do that. F of -2, well, that means we're going to take f of x, and everywhere we see an x, we're going to replace it with a -2. So that's f of x. G of x, x plus 7. So note there's a lot going on the board here, but these three terms are all coming from f of -2. That's our f function. These two terms are coming from g of -2, our g function. And what I'm doing with these two things is adding them together. At first glance, man, that looks like a ton of work, doesn't it? Except all I'm really doing here is a bit of calculation, a bit of arithmetic. This is something that maybe you want a calculator to help you out with, or you can just walk through it step by step. Starting with that -2 squared, well, -2 squared is 4. 4 times 2 is going to give us an 8. We then have the opposite of -2. That's a positive 2. And then we have that -12, and it's still just a -12. 8 plus 2 is 10. 10 minus 12 is -2. That's our f of -2. Taking a look at our second function, that -2 plus 7, well, -2 plus 7 is just 5. So what are we doing with all of this? Keep in mind, this was an addition problem. This whole thing was an addition problem. So we can continue bringing that plus down. -2 plus 5 gives us 3. So not a whole lot extra being added here. We're just evaluating our functions instead of just finding the generic function for x. Let's take a look at a subtraction example. With subtraction, we do keep in mind here, we are subtracting an entire function. So I'm taking all of f and subtracting all of g. So f of x, that hasn't changed. This will be 2x squared minus x minus 12. And if you're wondering where that 8 is coming from, that was our given value that we're evaluating this function for. And then I'm going to subtract g of x. And this is where we want to be careful. Just like with the generic ones where we were just using our x instead of an actual value, we can put those two functions in parentheses to remind us that we're subtracting an entire function, in this case g, which is x plus 7. We are subtracting an entire function, g of x, from f of x. Those parentheses can be helpful in making sure there aren't any arithmetic errors here. So now we're evaluating f of x at 8. Well, 8 squared, that's going to be 64. Multiply that by 2, and we get 128. The opposite of 8 is -8, and that -12 is just along for the ride. So 128, take away 8, that gives us 120. Take away 12 more is 108. Jumping over to the right side of this expression here, we have 8 plus 7. Well, 8 plus 7 is just 15. So really all we're doing here is taking 108 and subtracting 15. 108 minus 15 is -3. Keep in mind that if you're using a calculator to try to do a lot of this work for you, some calculators, you could put this entire first expression in, Make sure you remember the parentheses if you do that. If you forget those parentheses for this expression here, the second one for g of x, you will get an incorrect answer because your calculator won't add the 8 and the 7 before performing the subtraction. So I recommend using the technology if you're comfortable using the technology. Just make sure you're doing it appropriately. Let's do a multiplication example. So once again, multiplication, we are taking f and multiplying it by g, but now I'm evaluating both f and g at -1. So I'm taking f of x and multiplying it by g of x. And our x value is -1. So this is 2 times -1 squared minus a -1 minus 12. All of that's coming from f. And then I'm going to multiply times g of x. G of x, g is just x plus 7, since x is -1. We're going to take that -1 plus 7. And again, all of that's coming from g of x. So if you like, you can still throw in those parentheses. It's less important for this numerical example than it was for the previous example, the ones where we were just doing subtraction. However, again, if you're trying to use a calculator to evaluate all of this together, you will need these parentheses. Because again, your calculator is only going to do the 12, the -12 there times -1. It will not keep that 7. It will not take care of this plus 7 correctly if you don't include the parentheses. So let's evaluate this. -1 squared, that's just going to be a 1. 2 times 1 is 2. The opposite of -1 there is a +1, and that -12 just hanging along. Multiplying that by g of -1, that's a -1 plus 7. And -1 plus 7 is just 6. And we can keep going. 2 plus 1 is 3. 3 take away 12 is -9. So when it's all said and done, we're multiplying -9 times 6. -9 times 6 is just -54. If it feels like we're just doing a whole bunch of arithmetic here, yep, you're right. So we've done an addition, we've done a subtraction, we've done a multiplication. Hey, you knew it was coming. Let's look at a division problem. Same two functions as before. We have our f, we have our g. So I'm going to take f, which is 2x squared, and evaluate it at 5. 2x squared minus x minus 12. All of that is going to be over 5 plus 7. Again, if you're concerned about that 5, that was our given value that we are evaluating this function at. So simplifying this a bit, 5 squared is 25. Doubling that will give us 50. From that 50, we're subtracting the 5 and a 12. In the denominator, 5 plus 7 is just 12. So let's clean up that numerator a little bit. We still have a 50, take away 5, which is 45. And 45 minus 12 will be 33. You can go ahead and throw that in your calculator to double check. Your calculator will be able to simplify that fraction for you, which of course we haven't done yet. Your calculator will be able to simplify this fraction for you. Note that both 33 and 12 have a factor of 3 in common. 33 divided by 3 is 11, and 12 divided by 3 is 4. So there we have a fully simplified, fully reduced answer. No big deal. At this point, this is everything that you need for that first set of practice problems. So you have a handful there where you're just doing f of x plus g of x with no number, and then you'll have some where you're doing f plus g and we are putting in a number. Different techniques required for both of those. Definitely try those practice problems, work together. If you have a question, raise your hand, let me know what you need. I'm happy to walk through a couple of those with you. If that's what you need, just let me know, and I'll see you soon.